students, in nitro compounds, now we are going to learn the chemical properties of amines. And C6H5 means it is benzene. One of the hydrogen is replaced with two nitrogen, that is called as diazo. And one more X. X means it may be a chlorine, bromine or some other anion. Now this compound name is benzene diazonium salt. We are going to learn now benzene diazonium salt preparation and their resonance structures. Rest of the lesson in PPT.
When primary amine reacted with methyl bromide means it is a alkyl halide. That bromine reacted with the hydrogen of primary amine. Then instead of hydrogen we are going to add CH3. So now this product, it is a 2-degree amine. How it is 2-degree means the nitrogen containing, that amine containing two alkyl group, one is R, another one is methyl, so we get 2-degree amine. And suppose the primary amine, it reacted with the 2 mole of methyl bromide means we are remove 2 hydrogen and 2 hydrogen. Instead of 2 hydrogen, if we add 2 methyl means that remain that product 3-degree amine. How it is 3-degree means around the nitrogen we have 3 alkyl groups, so it is a 3-degree amine. Suppose the primary amine reacted with the 3 mole of methyl bromide, we get quaternary ammonium salt. The nitrogen containing lone pair electron, that lone pair electron given to bromine, so it becomes a positive character. Nitrogen becomes as a positive character. The positive character attract the bromine, so we get RnCH3 thrice and Br minus. Here 2 mole of HBr is left out, so remaining the CH3Br only are going to be attached with the RNH2, so that we get the quaternary ammonium salt. Primary amine and secondary amine undergo acylation reaction. What is acylation means we are going to add the acetyl chloride with the primary or secondary amine, or otherwise we are going to add acetic anhydride with the primary and secondary amine. First see the reaction. In ethylamine, it is a primary amine. When it is reacted with the acetyl chloride, one of the H from the ethylamine is taken away the chlorine from the acetyl chloride. Remaining thing we added means we get C2H5NH Here the CH3CONH is called as acetamide, and C2H5 is ethyl. That ethyl is attached with the nitrogen, so the name of the compound is N-ethyl acetamide. The same way, if you react the if the ethylamine is reacted with the acetic anhydride, we get the same product N-ethyl acetamide. Next one, Scott-Bowman reaction. This Scott-Bowman reaction especially for aniline with benzoyl chloride in presence of pyridine or sodium hydroxide. That acylation and benzylation are the nucleophilic substitution reaction. Nucleophilic means nucleophile means it is a negative character. The negative character attract the nucleus. So nucleus is a positive one. So nucleophilic substitution reaction here. Then aniline formula C6H5NH2. That hydrogen it combined with benzoyl chloride chlorine. So that remaining thing we added mean we get C6H5NHCO C6H5. The C6H5CONH is called as benzamide, and C6H5 is called as phenyl. That phenyl is attached with nitrogen, so that N-phenyl benzamide. Reaction with the nitrous acid, we get the nitrous acid when the sodium nitrite is reacted with the HCl. Now see the primary amine. For example ethylamine we are going to take, that is reacted with the nitrous acid. How we get nitrous acid means when the sodium nitrite is reacted with the concentrated HCl. Then here the ethylamine instead of 2 hydrogen, amine having 2 hydrogen NOMA, the 2 hydrogen removed as a 2 moles of water. When it taken away the 2 oxygen from nitrous acid and 1 hydrogen from HCl. Now the green color underlined nitrogen and then chlorine, it attached with C2H5N, we get C2H5N2Cl, that is ethyl diazonium chloride. It is unstable one. Once again it reacted with the water. How can you split means H plus OH minus. The OH minus is attached with the C2H5, we get ethanol, and then remaining H plus reacted with the Cl, we get HCl, and N2 is liberated as nitrogen gas. So the ethylamine, when reacted with the nitrous acid, we get the ethanol as a product. The next one, aniline. Suppose aniline reacted with the nitrous acid at low temperature 273 to 278 Kelvin. First we are getting benzene diazonium chloride like a ethyl diazonium chloride only, but when compared to the ethyl diazonium chloride, benzene diazonium chloride is a stable for a short time. Afterward only slowly decompose at low temperature. This type of reaction is called as diazotization. Keep it in mind, this question is very important one. Diazotization means when aniline reacted with the nitrous acid. How can you get the nitrous acid means sodium nitrite reacted with the HCl in the in under the Kelvin 273 Kelvin, it gives benzene diazonium chloride. That reaction is called as diazotization. Secondary amine, when it is reacted with nitrous acid, it gives N-nitrosoamine. It is a yellow oily liquid. It is insoluble in water. First of all, see the aryl secondary amine. For example, N-methyl aniline. It contains aryl as well as methyl, so it is a secondary amine. When it is reacted with nitrous acid HON double bond O. Here we are going to remove the water. I indicate in red color. So we get the N-nitrosomethylphenylamine. Nitroso means N double bond O is called as nitroso. The nitrogen containing N double bond O, that is called as nitroso, and then nitrogen containing CH3, it is a methyl. The same nitrogen containing benzene ring, that is called as phenyl. So name of this compound is N-nitrosomethylphenylamine. It is a yellow oil. This reaction is called as Lieberman's nitroso test. The next one, suppose alkyl secondary amine is reacted with nitrous acid, mean we get the same N-nitrosomethyl-methanamine. It is a yellow oil. Now see the example. N-methyl-methanamine is reacted with nitrous acid. The N-methyl-methanamine is a secondary amine. Why it is a secondary amine means the amine containing two alkyl groups, so it is a secondary amine. Here also we are going to remove the water. Red color I indicated. So we get the N-nitrosomethyl-methanamine. It is a yellow oil. When tertiary amine reacted with the nitrous acid, so far we studied nitrous acid with the primary amine, nitrous acid with the secondary amine. In this slide we are going to study the nitrous acid with the tertiary amine. The tertiary amine gives trialkyl ammonium nitrate salt, but this salt is soluble in water. Now see the first example. CH3 thrice N means it is a trimethylamine. Around the nitrogen we are having three alkyl groups, so it is a tertiary amine. Plus with the nitrous acid, it gives the nitrogen containing lone pair electron. The lone pair electron given to NO2. The NO2 is become as minus, so nitrogen become as positive. The positive attract the negative, so that we get trimethyl ammonium nitrite. The next one, aromatic trichoniamine. Here aniline formula we know very well. When benzene is attached with the NH2 means it is called as aniline. Instead of the two hydrogen in amine, we are attaching to CH3 means it is a N, dimethyl aniline. Yeah, that it is a tertiary amine. When it reacts with the nitrous acid, it gives para-nitroso N, dimethyl aniline. See that in para portion we are having N double bond O. It is called as nitroso, and then nitrogen is attached with the 2-methyl group, so that it is a N, dimethyl, and then benzene containing nitrogen means it is a aniline. Mustard oil reaction. This reaction is when primary amine reacted with the carbon disulfide, it gives alkyl isothiocyanate. When the primary amine, that is aryl amine, it reacted with the carbon disulfide, it gives phenyl isothiocyanate. Let's we see the example for first one, methylamine. Methylamine when reacted with the carbon disulfide, that we get the one product N-methyl dithiocarbamic acid. It is a just addition of methylamine and carbon disulfide. Afterward, when mercury chloride is added, we removed Hg and S, that is mercury sulfide. I indicated in orange color. Afterward, you see the rose color underlined element alone. H and another H rose color is eliminated. That 2H is combined with the 2 chlorine of mercury chloride. We get 2HCl. Remaining thing what we having means CH3NCH. That is called as methyl isothiocyanate. That thio means sulfur. Then isocyanate means NC called as isocyanate. Here NCS, that is called as isothiocyanate. It is a mustard oil smell, so that it is mustard oil reaction. The next one, 2 mole of aniline. Aniline is a primary aryl compound, primary aryl amine. When it is reacted with the carbon disulfide, it gives one compound, that is sulfur diphenyl thiourea. We are going to remove the hydrogen sulfide, so we get the sulfur diphenyl thiourea. When it is reacted with the concentrated HCl, we get phenyl isothiocyanate. Here we are going to remove the 2 hydrogen from the sulfur diphenyl thiourea. We get phenyl isothiocyanate. These reactions are known as Hoffman mustard oil reaction. This reaction is especially used for identify the primary amine. Aniline. In that aniline, the NH2 group, the nitrogen containing lone pair electron, the lone pair electron is conjugated with the benzene ring. It increases the electron density at the para and ortho position. So the electrophilic attack of the compound will obtain at the ortho and para position. Now bromination. Bromination means the aniline is added with the bromine in water or bromine with the acetic acid. We split the bromine Br plus and Br minus. Br plus is called as electropile. That electropile Br plus is incoming group. It is directed in the ortho position and para position by NH2 group, so that we get the 2,4,6 tribromo aniline. It is a white precipitate girls. This is the electrophilic substitution reaction of aniline. Next, to get the monobromo compound. In previous slide we get ortho position and para position, it is substituted, so that we get tri-substituted bromo compound we get. But instead of tri-substituted, we are going to get the monobromo compound, means the NH2 group first acylated. Why it is acylated means to reduce its activity of amine group, so that it first acylated with the help of acetic anhydride. Now see the example, aniline. First of all, it is reacted with the acetic anhydride. The CH3CO is called as acetic anhydride. Blue color I indicated, one of the hydrogen from aniline is taken away, and then CH3COO is added, means acetic acid is going to be removed, and then instead of that hydrogen we are going to add CH3CO. So it is a acetonilide. The name of the compound is acetonilide. And afterward we are going to add the bromine in presence of acetic acid. The bromine split into Br plus Br minus. The Br plus is the electropile. That electropile the directed by the acetonilide in the para position. So we get para bromo acetonilide. Afterward, we are going to add water. The water is H plus OH minus. That H plus the OH minus is attached by CH3COO. CO. It is indicated in blue color. Afterward, the H plus is attached in the NH. So we get parabromo aniline. That aniline, when acylated with acylator, the lone pair of electron on nitrogen is delocalized by neighboring carbonyl group by resonance. So that the resonance is indicated in the diagram. Then it is not easily available for conjugation with the benzene ring, so that the acetyl amino group is less activating than amino group in the electrophilic substitution reaction. Nitration. When the aniline is nitrated by with the help of nitric acid and also concentrated sulfuric acid, that amine group is a ortho and para directing group, so that we get orthonitroaniline and para-nitroaniline. See the product. Afterward we get tar colored tars, 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 because of oxidation. That another one, the strong as medium we are using here. So the aniline is protonated means proton is added with the NH2, so that we get NH3 plus. Benzene with the NH3 plus is called as anilium ion. That anilium ion is a meta-directing group, so that we get one of the product meta-nitroaniline also. With the orthonitroaniline, paranitroaniline, we get one more product meta-nitroaniline because of this anilium ion. And to get the para product nitro compound, the same way what we did in the monobromo product, means what we have to did an amine group is protected by acylation. The activity of amine group is restricted here by acylation. See the one, aniline is reacted with the acidic anhydride. We remove the acetic acid, so that we get acetonilide. Afterward, nitric acid is added, means nitric acid split into NO2 plus OH minus. Then the NO2 plus is directed in the para position by acetonilide. Afterward, when water is added, means water is split into H plus OH minus. Blue color indicated the OH minus is attracted with the CH3CO. Then H plus is added with the NH, so that we get para-nitroaniline. Sulfonation. When aniline is reacted with the concentrated sulfuric acid in the presence of pyridine and 453 to 473 Kelvin, first of all it gives anilium hydrogen sulfate. The NH2 is sulfuric acid split into H plus HSO4 minus. The H plus is added with the NH2. We get NH3 plus. The NH3 plus attracted the HSO4 minus, so we get anilium hydrogen sulfate. Afterward, the nitric acid is used, means we get sulfoanilic acid. The HSO3 goes to para position, so we get sulfoanilic acid. Then it is a equilibrium with deuterion. Deuterion means that NH3 plus and SO3 minus, it is in the para position, that is positive and negative in the para position, that is called as deuterion. It is in equilibrium with the sulfoanilic acid. Then aniline, it does not undergo Friedel-Crafts reaction, that is alkylation and acylation, because aniline is a basic in nature. It denotes lone pair of electron to the Lewis acid aluminum trichloride, which is used in the Friedel-Crafts reaction as a catalyst, and it forms a adduct. Adduct means just a addition compound which inhibits the further electrophilic substitution. In Friedel-Crafts reaction, electrophilic substitution reaction will occur, but this aluminum chloride, it formed the addition product with the aniline, so that addition product inhibits the electrophilic substitution reaction, so that the Friedel-Crafts reaction never undergo with the aniline. Diazonium salt. Di means 2, azo means nitrogen. This compound containing 2 nitrogen, and also it is a salt. This diazonium salt we can produce with the help of aromatic amine. When it is treated with sodium nitrate plus HCl, we get the diazonium salt. Some of the example is given. Benzene diazonium chloride means benzene, to diazo means 2 nitrogen and it containing chlorine. And para toluene diazonium bromide, toluene means benzene containing CH3 means that is called as toluene, and in para position we containing 2 nitrogen, so diazo, and bromine is having, so that bromide. So this is the para toluene diazonium bromide. The next one, in para position it containing nitro as well as diazonium tetrafluoroborate. So it is a para nitro benzene diazonium tetrafluoroborate. Benzene diazonium salt, it contains more resonance structure by dispersal of positive charge over the benzene ring. So which one having more resonance structure? It has the stability. So see the resonance structure. First, in resonance structure, the nitrogen, one of the nitrogen is positive, another nitrogen containing lone pair electron. The triple bond, that electron travel to nitrogen. So the one of the nitrogen already in positive, another nitrogen becomes negative. And the C2 carbon and C1 C2 carbon containing double bond, the double bond electron goes to C1 and then nitrogen. So the C1 and nitrogen bond now double bond, and the C2 carbon loses its electron, so that it possesses the positive character. And in the second structure, between the C4 and C3 electron goes to C3 C2, so that the C3 C2 now becomes double bond, and the C4 electron loses electron, so C4 carbon now becomes positive in the third structure. And again the C5 and C6 electron goes to C5 C4, and C6 electron loses its electron, so that C6 carbon becomes positive. And the fourth structure, the nitrogen having double bond, which nitrogen means the C1 carbon attached with the nitrogen having double bond, that double bond goes to C6 and C1. So now C6 C1 is having the double bond character in fifth structure. And one more, that nitrogen also give the lone pair electron to the C1 and nitrogen, so it possesses double bond character in the fifth structure. So thus we have so many resonance structure in the benzene diazonium salt, so it is a stable one. Now we are going to see the preparation. We already learned this preparation in page number 219 under diazotization reaction. Please refer that reaction also. The same reaction only we are going to learn here. What does that means? Aniline when reacted with the sodium nitrite and 2 moles of HCl. Sodium nitrate and 2 moles of HCl combined with the gives nitrous acid. This reaction undergo 273 Kelvin to 278 Kelvin, because at low temperature only benzene diazonium chloride is stable one. So that we have to prepare this reaction at 273 Kelvin to 278 Kelvin. Physical properties of benzene diazonium chloride. It is a crystalline solid, colorless, and it is a stable one under cold water only. In warm water it reacts with the water, so that it is a stable one in the cold water only. And it conduct the electricity because it contains ions, so that it conduct electricity. And also in aqueous solution they are neutral. The next one, benzene diazonium tetrafluoroborate. This one is stable at room temperature, when the other benzene diazonium salt are stable at cold condition only, they are stable. At room temperature, which diazonium salt is stable means the benzene diazonium tetrafluoroborate only stable at room temperature. Now we are going to learn chemical reaction in benzene diazonium chloride. There is two category. One is replacement reaction, another one is coupling reaction. In this replacement reaction, the nitrogen, 2 nitrogen is having in benzene diazonium chloride, the 2 nitrogen is going to be lost, and instead of that nitrogen that is replaced by some nucleophile like halogen, cyanide and H plus and OH minus. So this is type A reaction. And type B reaction, coupling reaction, means we never lost the nitrogen. The nitrogen group as it is we are having. So that is called as reduction of diazo group, and also the coupling with some other compound. So there is two category in chemical reaction of benzene diazonium chloride. We will study in next video.